So once again, good morning. So we are going with an online lecture on data structure and its applications, dealing with the module 2. So in today's class, we are going to discuss with a new topic in the module 2. So new topic in the module 2, that is, you go with this particular concept, that is queues. Okay. So till now in module 2, we have gone with 3 chapters. So first chapter is stacks, second chapter is recursion, and third and last chapter of the module 2, it is queues. Okay. So till now we have discussed about stacks and recursion. So recursion, you have to go through all the programs. So each and every program, what we have did. So each and everything is very important from the exam point of view. So certainly there are 6 to 7 programs, I think so. So all the 7 programs are very important for the exam point. Okay. So in recursion, very important concepts are, first one is factorial, second one GCD LCM, third Fibonacci series, fourth prime numbers, fifth multiplication, sixth tower of Hanoi. So all the 6 programs what you are having, so are very, very important. Okay, go through the programs with a concept. Understood? So recursion will make use of stacks. Now you come for the another data structure. So what is the another data structure? So new data structure is queues. So you will be familiar with the word queues. So queues, how you are going to insert and how you are going to delete. So in stack, so come for stack. So anybody can tell how you insert and how you delete? In stack, how can you insert the values and how you delete the values? So insertion and deletion will be at same end or different end? You should answer here. Yes, you can insert and delete through push and pop. Okay. So you are going to insert and delete through same end. Okay, good. Arshita SJ. So you are right. So you are going to delete the insert as well as delete the elements. So you are going to insert and delete the elements from the same end only. But come for the queues. So where you come across the word queue. So where you come across the word queue, you are standing in the, so this is similar to queue. So that means where you stand in the queue to get something. Okay. So take for example, if you are going for a movie. So take for example, you are going for a movie. Okay. You are going to buy a ticket in the counter. So that is in the counter, everyone who are going to watch the movie will be on the queue. So how you insert into queue and how you delete from the queue, whether it will be at the same end or different ends, that you have to see it here. So see in this particular thing, so you are, so before I will take this example, see here, this is the queue. Okay, so go for this particular concept. So how many members or how many elements are there in the queue? 25, 30, 12, 37 and 67. So totally we are having 5 elements in the queue. So who is the first one to be inserted into the queue? So where you insert the elements, so insertion will be at the rear end and deletion after the ticket is given, deletion is at the front end. So keep in your mind while going for the queue, if you are joining the queue, it will be at the rear end, and if you are going out of the queue, it is called as a front end. So keep in your mind. So which are the 2 ends you are having? So it is the rear end and front end. So rear end, when you will get the rear end? When you are joining into the queue. That means when you are placing an element into the queue, we call it as a rear end. And when you are going to delete from the queue, that is called as a front end. Because front end means you are in front of the ticket counter. So in front of the ticket counter, once you take the ticket, you will be moving out of the queue. So that's why we call it as a front end. But inserting all the elements will be at the rear end and deletion will be at the front end. Understanding? So that is the general concept of the queue. So first you got it? How many ends you have in the queue now? You can type in the chat box. How many ends you have in the queue? 2 end. Okay. So where you insert the element? Where you insert the element? Rear end. Okay. So where you delete the element? Delete the element? Front end. Okay. So there for now, this is enough. Okay. But you see, so the element which is inserted first will be deleted first. So keep in your mind. So which is the first element here? So come for here. Which is the first element you have inserted? 25 is the first. 25 is the first element. Second element is 30. Third element is 12. Fourth element is 37. Fifth element is 67. So which is the first element inserted? 25. Which is the first element deleted? It is also 25. So that's why we tell it as Q is the first in, first out data. Which is the first in, it is 25. Which is the first outed? It is also 25 only. That's why we call it as Q is a FIFO. Stack is LIFO. Q is a FIFO. Stack means last to be inserted. Last in will be first out in stack. Whereas in queue, it is first in, first out. If you are the first in the queue, you are the first one to be removed. Understood? So now under that, you see what are all the things you are going to study. So now you got understood the concept of queue, right? Got the concept of queue? Okay. So kindly reply me whatever I ask you. So queues. So there are two concepts we will be discussing in queues. So first one is linear queue, second array representation, and queue operations with a program. Similarly, you go with a circular queue, that is definition and advantages of using circular queue over linear queue. Then you go with array representation, queue operation, and program. So very, very important are queue operations and program. Okay, in order to understand the queue operations with the program, you have to go with this advantages and array representation. Okay. So now you come for the concept of queue. So as I've already told you, queue is a LIFO data structure. LIFO means the first element will be inserted into the queue will be the first element you are going to delete. So first in, first out data structure. Okay, so items are processed and deleted according to the sequence of arrival. So understand here, the items are inserted from rear end and deleted from the front end. So what is the abstract data type for the queue? So abstract data type, keep in your mind, very, very important. Abstract data type is very, very important. So in each and every question, you will be getting like this. So queue abstract data type is given as first is queue name. So inside queue, there are set of elements. So that elements we take it as size. So that size will, so size with two ends. One is front end, the other one is rear end. So these are the inputs what you are going to give for the queue. So queue will consist of set of elements. So set of elements is nothing but size with front end and rear end. These are the two pointers what you are going to check. So rear end is used for insertion and front end is used for deletion. So using this, what are all the things you are going to do? insert queue, delete queue, display. So similar to stack also you have push, pop and display. Go for the stack program. There you will be getting push, pop and display. With the same thing here we are taking it as insert queue, delete queue and display. So these are the operations what you do inside the queue, and these are the elements of the queue, and this is the queue name. Okay, so items will be always inserted at rear end and deleted at front end. So come for the array representation. So coming for the array representation, so first you understand the words clearly. So front, so first one is front. So totally the words array representation, first is front, next you go with rear, next insert, next delete, and finally with a display. So what you are going to do it here? So come for the front. So front will tell, it will get the front element from the queue. That is queue of front if queue is not empty. So if queue is not empty, if it is empty means, so there is no element. Okay, so if queue is not empty, it will get the front element from the queue. So here you see here, this is the elements. Okay, so these are all the elements you are having. So many elements, 10, 15, 5, 20, 19, 50. So this is the queue. Okay, so you are inserting from where? You are inserting from, this is called as a rear end and this one is called as a front end. Okay, so where you have the empty spaces, so where you are going to insert, so first element inserted is 10, second element is 15, third element is 5, fourth element 20, fifth element 19, this one is sixth element. So if you start from 0, this will be the fifth element is 50. So these two are empty here. Understood? So for front end, we consist of element that is 10, and rear end, it contains few element 50. But remember here, front end and rear end are the pointers. Front end and rear end, we consider it as pointer. So similar to stack means there is only one end, that is top. So top is considered as pointer, but where you insert the element at the top, when you delete the element, it is also from the top only. So at that time, so front end will contain the address of first element and rear end will contain the address of the last element. So keep in your mind, front end will contain the address of first element and rear end will contain the address of the last element. So front end will have the value 10 with address 5000 and rear end will have the value 50 with address 5020. Understood? So come for the rear. To insert the item from the rear end, if queue is not full, so you can insert the element from the rear end if queue is not full. So front will get you front element of the queue if it is not empty. Okay. So next you come for the insert. So that means addition of an element to the queue. So keep this one in your mind. So it is a addition of an element into the queue. Okay, so adding the element will be performed after checking whether it is full, queue is full or not. Understanding? So what we tell, so adding the element will be performed after checking whether the queue is full or not. So you should understand here, it is similar to Stack Overflow. That means if stack is full, you are not going to insert the element. So similarly, if queue is full, you cannot insert the element. So how you check? So if rear is less than size, if you rear, there you are taking it as top double equal size. Top double equal size. But here you're taking it as condition rear less than size. If rear is less than size, so what you will tell? The array is not full, then store the element. Okay, so but you see here, so how you are going to insert? So if rare is less than size means array is not full, then you store the element at q of rare and increment rare. So similar for the stack. So stack we are incrementing the top and inserting the element. Similarly here, store the element of q of rare and increment the rare end by 1. So increment the rare and place the element. So similarly, if rare double equals size, so what we call it as? It is called as a stack overflow. So there you are taking it as top double equals size. So top double equals size is for stack overflow, but rare double equals size, we call it as skew overflow condition. Understood? So similarly, you come for the deletion. So deletion means removing of the element from the queue. It can be removed. Okay, so element can be only be removed when there is at least an element, that is rare is greater than 0. So now element of q of friend can be deleted, but all the remaining elements has to be shifted by left by 1 position. So keep in your mind, if you are deleting this 10 element, okay, so this element you can delete, but you have moving all the elements. So if this one is removed, 15 will come in place of 10. So if 10 is removed, what should be done? Shift 1 index. Okay, so this is called as the insertion at the rear. So insertion at the rear, so it is taken here. So rear end which was at, so rear end which was at address 5020 goes incremented and places the value. So similarly when you delete, so this is a deletion. So deletion you see element is 10, but here it is element is 15. So once you delete this, all the elements are pushed from left here. So see the diagram, all the elements are pushed here. Okay, so that is you have to, once you delete, so you have to move all the elements by 1 position. Okay, so that element of second q with second element will be the first element. Okay, so now you come for the last one, display. It will print all the elements of the queue. Okay, so are you understanding? Kindly respond here. Getting? Any doubts you can ask me. Want to tell me again? No problem, I will tell. Want me to repeat or shall I continue? Okay, if you have understood, tell me the condition for overflow. Condition for queue overflow. Can you tell the steps for queue insertion? So what are the steps you have to do for queue? What is the first step for queue overflow? Queue insertion, sorry, queue insertion. Okay, first step, check that rare is less than size. Okay, then so see here, first step is rare is less than size. So second step is increment the rare. So then third step is insert q of rare is equal to element. So these are the three steps you have to go through. Okay. So what are the three steps you have to go through? So first one is, so first step you have to do is check whether rare is less than size. If it is less than size, then array is not full. So at that time, you increment the rare. So see the second diagram I have given here. So rare is at address pointing at which address? 50. So if you want to insert the element 66, what you are doing? You are incrementing the rare. Increment the rare and place the element at the rare. So that is the second one. So second step is rare plus plus. So once you increment the rare, so then you can place q of rare is equal to element. So these are the three steps what you have to do for q insertion. Okay, so similar to stack only. First in stack what you will do? First you will check for top double equals size. Second top plus plus. Next you will go with s of top, stack of top is equal to element. But the same thing, but you are going here, you are going with a rare. Okay, so now you can you come with the steps for deletion. What are all the steps for deletion? Condition number one, rare greater than 0. Okay. Next, second, check. Okay, you have checked. Now, what is the thing you have to do? After layer, if rare is greater than 0, okay. Next, where you are going to delete? You are delete front of minus minus. Okay, good. Okay. So front of minus minus. So you are right. So you are going, that means from front end, you are going taking the element out and decrementing the front end, because the one of the element will go out at that time. The second element which was there will come to the first element. So element number 2 will come at the position of element number 1. So from 2 position, you have gone to one position. So at that time, we call it as, we are going to decrement. Okay, the two steps you have. So first one is checking for rare is greater than 0. Next you go with q of f minus minus. So that we will go with the next one. So this is the program we have. Okay, so this is the program for linear queue. So first you go with, so many functions are there. So this is inserting at the queue. This one will go with deletion and this one will go with the display. Okay, so for that, this is the main program. Understanding? So this is the very, very important program what you have to go. So first you start from the main. So keep in your mind, you are having the stack elements. So size. So first you go start here, max hash define max 5. That means It is the size of the queue. So size of the queue will go with how many elements? Maximum 5 elements. Okay. So start from the main, then you go with the insert. So you can easily start with the insert only. So if what is the steps we have taken, you see. So insert queue means what are all the parameters? For the queue, you are inserting the element. So keep in your mind, for a queue, you are inserting the element. For a queue, you are inserting the element. Okay. So if rare double equals max minus 1, or you can go with max also. So first condition is if rare double equals size. So in place of size, you are having max. If rare double equals max minus 1 or max, q is full. Okay. So if q is full, next, if not, what you will do? Increment the rare. So increment the rare and q of rare is equal to item. Okay, if front double equals -1, you make it 0. So this is to be done initially, because you see here, initially rare will be -1 and front will also be -1. If rare double equals max -1, so what you will do? Rare plus plus q is full, else rare plus plus q of rare is equal to item. If front double equals -1, front is equal to 0. This is for first type. Okay, so this is the insertion. Similarly, you come for the deletion here. So first you check for it. Front is -1. So if front is -1, q is empty, nothing to delete. If front is not -1, so what you will do? D is equal to q of front. Q of front is equal to 0. It is front minus minus. So this is what, when you are going to do front. So this is a small change you are having. So it is front minus minus. So D is equal to Q of front. Okay. So D is equal to Q of front. Q of front is equal to 0 and front minus minus. When all the elements are deleted, what you will do? If front double equals rare plus 1, front is equal to rare is equal to -1. That means when all the elements are deleted, where you will get? So rare will be at the last, front will be at the front. When all elements are deleted, both will point to the same block. So that's why we take it as front. When all the elements are deleted, front is equal to rare is equal to -1. If the elements are there, front will be 0, rare will be 1. Front will be 0, rare will be 2. If you delete all the elements, what will happen? So front and rare both will come with a -1 only. So that is this one. So what you are going to do it here, if front double equals -1 means there is no elements. So stack q is empty. So this is underflow condition. So else mark the element, that is the element is equal to q of front. So q of front, you make it 0 with front minus minus. So if both the front and rear are same, that means you mark the front is equal to rear is equal to -1. So return D. Okay, when all the elements are deleted, what will happen? Front and rear will be having the value -1. So next you come for the display. Display is nothing. You are going to display the contents. So you are displaying from 0th location up to maximum location, keep on incrementing with printing q of x. Okay, so this is the display. So now you come for the main. You start with the option. Option means there are 3 options, one for insert, second one for delete, 3 for exit. So at that time, option q of max is equal to 0 item. So while of 1 means it is true. So printf, always it will be 1 means it will be executed. So printf linear queue operation, first for insertion, deletion and exit, you are going to enter the option. So if option double equals 1, what will do? It will go for insert. So at that time, enter the element, scanning the element. So insert q, you are calling the function. So this is a calling function. So this is a calling function. After insert, you are going to display the queue. Else, if option is not 1, you are going with delete. So deleted item is, you are calling, this is the function call. Sorry. So delete q of q. So delete q of q and you are going with a display. So if both are not there, you are going with the option 3, that is exit. So it will come outside of the loop. Okay, this is the program for linear queue. And are you getting? Are you getting? Use this for attendance as the attendance link. Have you understood the program? I'm asking you people only. Have you understood this program? So kindly use this as the attendance link. Everyone answered the attendance? So this is up to this particular class. Remaining we will see in the next coming class. Thank you. I will be ending this particular session. Go through in YouTube link. Okay. Thank you.